Okay, good evening, friends. Hello.
Good evening, sir.
Yeah. So, you have any questions in whatever we have dealt till yesterday, especially vernier calipers? Hello. Right. So, silence, golden silence means you have no doubts. Right. Let me presume so and continue. And most importantly, see, yesterday we have solved a couple of problems wherein the reporting at the end, if you remember yesterday, okay, we had 19 and 9 plus or minus 9%, things like that, where we have judiciously and very cautiously worked out on the significant digits and the reporting error and all the things. Please contemplate on that. That is very important. Now we will take up the next important instrument. I think you have handled the screw gauge. Hello?
Yes, sir.
Yes.
Yes, sir.
And spirometer?
Yes, sir.
Both the things, yeah.
Yes.
Very good. So you are familiar with all the things. So in the case of screw gauge, as you can see here, the least count is what? The pitch. The pitch, which I know, I suppose all of you know, the division, the distance by which the linear scale, the distance that this circular head moves on the linear scale divided by total number of divisions on the circular scale. I suppose you know this, right? If since you have used it, you are quite familiar with this. But remember, least count is pitch divided by total number of divisions on the circular scale. Quite simple. Or pitch itself is equal to distance moved by the screw on the linear scale divided by the number of full rotations given. Okay? And of course, zero error correction is also there. I think you are all familiar with that, right? And then the spirometer, as you see here, okay. So it is used to find the radius of curvature, and this diagram, the second diagram, you really see here how the radius is measured there. So you get here the radius of curvature. Okay, here is given by h square plus d square by 2h. So here it is written in other form, L square by 6h plus h by 2. I think I suppose you are able to correlate both these formulas, the formula given here and the formula given here. Okay? Hello? Yeah, so here you see 3 readings are taken and the average of the 3 readings, you are writing it here, right? So if you do the manipulation, you are going to get the same answer here. Okay? Okay, fine. So this, because you have already used it, I don't have to once again elaborate on this. We shall tackle some numerical issues on this, right? Now this is another thing that we had just we had discussed this a bit, the precision and all. Just a word or two on this. Precision of measurement is determined by the least count of the measuring instrument. The smaller the least count, larger the precision. Okay, this is one form of defining it, but I don't subscribe to that definition, right? Because now if you see this this statement here, which is it? This statement you can see here. Accuracy is how close a given set of measurements, observations or readings are their true value. How close they are to their true value. While precision is how close the measurements are to each other. In other words, precision is a description of random errors, a measure of statistical variability. Now, I have explained this yesterday or day for yesterday. Once again, I will reiterate. Okay, so as I told you, say this is the bullseye, right? Right, this is the bullseye, and now that remember this bullseye here, right? So now supposing you hit the bullseye, I'm trying to explain this, right? And then you get the shots like this: one shot here, 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 one shot here. Okay, so you are getting many shots here. Now this is where you have to hit. I suppose all of you are understanding this. Hello? Hello?
Yes, sir.
So, you are playing the dart or something like that, so you are hitting it. So you have got the scores around this point. and then another person comes, he will hit the dart. Okay, so he will hit the dart, and he is going to hit the dart like this. One here, 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 one here. Now, what is the difference here? See, if you see these yellow dots here, they are closer to the true value. Okay, so the yellow ones, so the yellow ones here, so yellow dots, what does it imply? It means these values are more accurate. That is, this darting here is more accurate, okay, but less precise. Agreed? Whereas if you see these, they are forming a closed cluster, so they are more precise. Okay, but you see the proximity with this. Okay, every dot, the proximity of every dot here with respect to the true value is very far off, so it is less accurate. Now I am just showing you by a dart experiment here, but the same thing if you do it with readings. So you will have cluster of readings which are very close. Then you say the machine is very precise. Then you have got cluster of now one more thing, sorry, before I say. Supposing you have another set of a darting. Let me put it like this. Okay, another set of darting. Okay, now you see this darting here. What have you got to say about this blue dart? This blue color darting, what do you say? If you take the set of the darts with the blue, what is your conclusion? Quickly.
More accurate and more precise.
Yes, correct. They are more accurate and more precise. They are both accurate and precise. That is the answer. I think if you have answered this question, you have understood the meaning of this. So you see, what is accuracy and precision? You have got to write this definition, right? You got to write this definition. Okay, that's better. After having written this definition, then if you put this definition, it is fine, because now you see now what is the role of the least count when it comes to the precision of measurement. Okay, the precision of a measurement is determined by the least count of the measuring instrument. No, that is not. Okay, I don't prescribe to this as a definition. But one thing is sure: if the least count is small, right, then you can measure the precision much better. Hello, are you with me?
Yes.
In an instrument, if the least count is less, then it will be easy for you to measure the amount of precision much more better than if the least count is more. That is how you have to interpret the meaning of the statement. The smaller the least count, the larger is the precision of measurement. That is the outcome of the statement. So that's what I'm trying to tell you. When you read something, you have got to apply yourself and then try to understand it with the realities like this. Of course, accuracy of measurement of an instrument represents the closeness of the measured value to the actual value or the true value. Okay, how close it is to the cell. Or in other words, accuracy is a measure of the degree of closeness of a measured value to its true value. Okay, say the true value is 1 kilo. So if you are measuring something which is very close to that, if the measured value is very close to that, then you say the machine is more accurate. In all this, the sum and substance is very clear. You cannot, for whatever reason, say, okay, this is the right reading. Your reading is close to the true value. How close? Well, there is a system of reporting. If you report like that, well, you are able to communicate the truth. That is the meaning. That is why, this chapter, the significance of this chapter or the importance of this chapter is, to train our mindset or to establish a convention wherein truth is reported to the maximum extent. Is it clear? Hello?
Yes, sir.
Now zero error. Okay. So this is something which all of you know. All instrument utilizing threads have backlash error which belongs to the random category. So I have explained the zero error needless to say. Can I proceed, students? Hello? Yeah. So now let's look at this problem. Find the thickness of the wire. If you put a wire between the jaws, okay. So here, well, but I don't think you can see from there. Can you see what are all the readings and all there? Can you see the readings?
No. Can you enlarge them?
Can I enlarge? I think I'll enlarge. Then you will be. Okay, I'll do that. Now is it possible?
A bit more.
Bit more. Okay. Enough? Hello?
This is that means can
Everybody cannot see or only Adil cannot see? Hello?
I
You can see? No. But if I make it very big, then you know it will be slightly smudged. Now, can you see? Is it improving? Hello? Not even. Okay, now I think it's better. Can you spot the readings here? This is before the wire is inserted. This is after the wire is inserted. So the question here is, well, find the thickness of the wire. So what are you going to get from this diagram? And what are you going to get from this diagram?
Like zero error we can.
Excellent. What is the zero error there? What is the zero error?
So minus 0.5.
Minus. No, you see, what is the reading here? 1, 2, no, it is 3. 1, 2, 3. The reading here is 3. 1, see here. This is 1, 2, 3. Okay? Hello? It is 3. Okay. So what is the zero error? Because now you know the standard screw gauge. Standard screw gauge, the least count will be what? Hello? What is the least count of this? Why are you not talking? Hello?
0.01.
0.
0.01
Yes, 0.01 what?
millimeters.
Tell it properly, man. You are all physics students. You cannot eat words like that. 0.01 millimeters. What is your problem in to tell like that? What is your problem? This is the way to tell, no? 0.01. See, that is not the way the student of physics speaks. See, that's what you know. This chapter is all about conveying maximum truth, communicating maximum truth, and your communication is so weak. Come on, learn these things. I am telling all of you. See, you will be watched when you are going to take up a job or something. All these things will be watched. So better improve your communication skill, your speaking skills, etc. This is the only time for all of you to change, right? So the least count here is how much? 0.01 millimeters. So the zero error. So what is the zero error here? Hello? 0.03 millimeters. Correct?
Yes, sir.
Right. Okay. Now you have put the wire here and then do the measurement. With the wire there, do the measurement. So you can see here 60. Hello? This is 60. This is 70. Hello? Are you with me?
Yes, sir.
Right.
So what is that meaning in that?
This reading, this reading, this reading. So this is 65, 66, 67. This reading is 67 here. This reading is 67, right? And what is the main scale reading here? This is 0, right? And main scale, I told you, main scale will be in what? It will also be in millimeters, right? So 10, 11, 12, 13 millimeters. This one. 13 millimeters. And this reading is coinciding, division is 67. Right. So what is the thickness of the wire? Okay? You are determined?
Yes, sir.
Tell now, I'm determined. Come on, all of you to speak and be confident. Don't be afraid now. See, there is nothing wrong. If you give wrong answer, it is okay. The process is to learn. Here, nobody is here to prove any point. I am not here to do judge you or do anything. I just want every student to learn. And that's precisely why I and you are here. Even I am enjoying it. Right. So the zero error is very clear, 0.03, right? Okay, then it is giving 7.6 mm in which there is 0.03 mm excess. Okay, so which has to be removed. So 7.67 minus 0.03, you get 7.63, right? I gave this as the 13 millimeters. No. It's recorded here 7. I'm sorry. I also read it wrongly here. So the main scale reading should be 7. That's what it's indicating here. And here it is 67. That I have recorded correctly. So 7 plus 67, 7.67. So this is valid. Okay. Anyway, the diagram, smudged and all, you are not able to see it properly. That's why it is. Okay. Hello. Are you fine?
Yes, sir.
Done. Sure. Thank you. Right.
Yes.
Okay, done. Thank you. I am wrong. I am sorry. So this bigger line is 5th line here. I read it wrong. 5th, 6th, 7th line. Right. So 0 correction, 0 is equal to minus 0 correction is equal to minus 0 error. Actual reading is observed reading minus 0 error, observed reading plus 0 correction. I think these terminologies. 0 correction, 0 error, right? Okay. Now we will be entering the zone of actually conducting the experiment, right? Hello, are you with me, all of you? I think you have conducted this experiment in the laboratory. Hello.
Yes, sir.
Right. You are determining the you have determined G at the place, right? Acceleration due to gravity using simple pendulum. Or what did you do in the laboratory? Come on, everybody speak up now. What did you do in the laboratory exactly? I want. What first thing is, what are the aim of the experiment that you conducted in the laboratory? Don't read this. What are the aim of the experiment? What was the aim of the simple pendulum experiment?
Yes, the time period of the simple.
You only determine the time period in the laboratory.
Is independent of the length of the.
Okay, so the first aim, what are the aims of the experiment? First aim was what?
Time period of the simple pendulum.
Yeah, so to determine the time period of the simple pendulum, isn't it? The time period of simple pendulum. Second aim, any other aim?
The mass of the bob or the size of the bob or the
Yeah, okay. Independent.
shape of the bob.
So to say independent of the size of the bob.
Yes.
Or the mass of the bob. Right. And any other aim? Hello? Any other aim? Only these two aims in the college?
Yes, sir.
Sure? Hello? Sure, you have only done this?
Yes, sir.
See, now let me tell you. See, here you see, you just have to watch it go up and down and write the time period. What is so great about that? Frankly speaking, that is not the aim of this experiment. Somehow, in the PU, this one they have manipulated it and they have written. Because see, that experiment to determine the time period of a pendulum experimentally. Time period of a simple pendulum experimentally is an experiment that is conducted at 9th and 10th standard level. Anybody from IISc syllabus here? Did you conduct this experiment in your school?
Yes, sir.
And what did you do there?
Yes, sir.
What did you do?
We calculated the time period and verified t equal to 2.10.
You calculated that. How did you calculate?
Not we found we measured the time period.
How?
in real
How?
time and
How did you measure?
we had a stopwatch.
Yes. So you count
we
you
took 10 oscillations.
right 10 oscillations you took and divided by 10. That's precisely what you did. Correct? Okay.
Yes.
So it means now this part of the experiment you have conducted in your high school. Correct?
Yes, sir.
And this part of the experiment.
Yes, sir.
So both you have conducted in 10th standard. Am I right?
Yes, sir.
That is precisely. So at the 11th standard, see 11th standard, this is not the objective of the experiment. I am sorry to say. This is not the objective. The objective of the experiment in 11th standard should be to determine the G value. Using simple pendulum, find out the acceleration due to gravity at the place where you are conducting the experiment. Did you get me, students? So here you see, you will have the simple pendulum, right? So you have taken a thread here. So what should be the qualities of this thread that you have taken in the laboratory? Come on, fast. All this is a part of this experiment. What type of thread have you taken?
Massless and limb extension.
Yes, you have taken very thin thread and what? What else? And?
In extension.
Yes, it is in extension. In extension, correct. That's right. Right. Okay, and then you have taken a bob, right? Hello?
Bob.
Right. So you have taken a bob. So your objective is to determine the G. So what is your objective is to determine G. So how will you determine G? Okay. So for that you would have written in your journal that we know that the time period is equal to 2 pi root of L by G. Correct? And therefore this implies G is equal to, right? G is equal to what? T square by 4 pi square into, am I writing right? I have to write it ulta, no? Hello? 4 pi square by T square, okay, into 1 by L. Am I right, students?
Into L, sir.
Into L, sorry. Right. Into L into this. So this gives you the formula. So now G is so and so. Now your job experimental. What you will do? Experimentally determine T. Okay. So for that you will have a setup like this, right? And then you will do 10 observations, correct? So you will make the pendulum to oscillate. Now if somebody would like to learn better, you can submit yourself. I will ask you what exactly you did in the laboratory. You will learn, I will learn, all of us will learn. So who would like to submit yourself? Somebody who has enjoyed conducting this experiment in the college. Come on, fast. Yes, good, Adil. And speak properly, Adil. No, Abhi, your mic is not good, so therefore I am not obliging you. Please, sorry. Okay, Adil, tell. If Adil is not here, somebody else can volunteer. Like Aditi's, Anushri's, okay, Naman's, Prabhu's, Saurabh's, whoever is there. If nobody is ready, then let Adil do. Okay, somebody wants to try? Okay, Adil, continue.
Yes, sir. So we start oscillations from a particular point, sir.
Pardon. See, you don't keep on moving your mic. They is doing kar sound. Aram se, keep it steady and speak aram se. What did you do first?
Calculate time taken for completing 10 oscillations.
So as soon as you went to the laboratory, you started oscillating the pendulum and you started calculating the. You took a stopwatch and you measured 10 oscillations. That's precisely what you did.
So we first added that particular mass over there.
Added that mass.
There was like for the very master.
Acha, you attach the mass to the string.
Yes.
You tell like that. Added. Okay, you attach the mass to the string. So before that, did you do something? Anybody?
The length of the string.
Yes, you measure the length of the string. Okay, length of the string. Okay, so you measured the length of the string. And then what did you do? So the length. So here in this formula, L is equal to Ls. Ls is length of the string. That is what you did.
Yes, sir.
Anybody else who did something else other than this?
So we also took the mass. We had that kind of a hook, sir. Also considered that mass.
Consider that length of the hook you consider.
It was a long hook, sir.
So you had a mass. See, come on, all of you to say. So you had anything like this. So what did you measure here?
From the top till bottom, the whole length.
From top till bottom, you measured this length, correct?
We also added that way.
Wait a minute. You measured this? Everybody did this?
Sir, from hook to the center of the mass.
From hook to the center of the mass. This is right. If you are taken till this, you are wrong, Mr. Adil. So this becomes the length of the hook. So therefore, the length becomes what? Ls plus this length. That is the length of that is the L that you have to use. So that is the first thing. That's the first mistake that you have done. And how did you measure this length?
Over the pressure suspension, sir, there was a scale attached to that.
Which scale?
Centimeter scale.
Centimeter scale. Which had millimeter reading?
Had millimeter.
So you are using a millimeter scale. So you have used a scale with least count 1 millimeter, correct? Yes, you should tell like that. See, in your journal, if you have not written like that, and if I am to correct your journal, I will definitely delete marks from you. I am telling you. If I come as an examiner, I am going to delete marks because this is what you are supposed to do in the laboratory. Okay, you have to specify which measuring instrument you have taken. So you have to say, like, I took a scale with least count 1 millimeter, okay, and then I measured this, right? Okay, fine. So what is the length? How did you write this? How much is the, if you remember in the laboratory, what was the length that you got? What is the length you got? And somebody remembers? Somewhat? Approximately 10 centimeters, 20 centimeters, what is it?
20 millimeters.
Hey, sab jor matado.
20 centimeters.
So how did you write there? You wrote 20 centimeters?
We converted that to meters.
Then what did you write?
0.2 meters.
You wrote 0.2 meters. Correct?
7.20 meters.
What did you write in this journal?
I wrote
So you are wrong. So a good examiner who comes to it, he will see these points only. At least now correct your journal. And I am telling you students, engineering college and further, and even when you are going to do project and all, be very careful about units. Very careful. So if you have written 0.2, your whole experiment is wrong. I am telling you. Right? You know that you have measured it in millimeters. Right? So supposing you have measured the length equal to something like say 22 millimeters. Okay? This you are going to write it in meters. How are you going to write it in meters?
0.002 centimeters.
Okay. Right. Come on, somebody else. In this exam, for you are going to determine the period, right? So what are you going to write here? Okay, you measured it in 22 millimeters, but you should write it in SI units. You should write it in SI units because this is in SI unit seconds. Hello, this you are going to get G in SI unit, and this also should be in SI unit. See, if you have to do this, so what are you going to? Anyway, you have made a mistake. Fine. So what are you going to do now? Assume that I am going to come as an examiner to you. Okay, then you have got time now to correct the journal. What are the corrections you are going to do? Are you going to keep it as 22 meters?
We can write 22 meters.
See, don't say we can write and all. We can write and all. I am not doing any Santibaji here with you, right? You tell me what you are going to write. You can write only one answer there. You don't have many possibilities here. What are you going to write in the journal? First, everybody do that. It's not only for Adil. I am speaking to the whole class. Come on, tell me.
22 into 10 to the power minus 3 meters.
20?
2 into 10 to the power minus.
Is that the way you have written? Anybody else? Correct it. Yesterday only I taught you how to write. Anybody? You should write. This is scientific notation, right? This is the scientific notation, right?
Yes.
Into 10 to the power of what? Minus 2. Right, minus 2 meters. Minus 2 meters. So this is what you are going to write. Got it now, all of you? So the journal writing is all about, which instrument have you used, okay, and what did you do? All the detailed procedure should be written, right? And you are going to have questions on this. Mind it, my dear students. Okay, so you measured this length. Then what else did you do? Tell me correctly what else you do. Everybody can participate. It's not just Adil. See, if I am scolding, it's not only for Adil, it's for everybody. Come on. Then what you did?
That is a particular mass, sir. We have noted down the mass.
You noted down the mass. Okay. So mass M is equal to what?
50 grams.
What should I write? What should I write? 5.0 into 10 to the power of grams you have written now. Hello?
0.5, sir.
You are going to write it in scientific notation, gentlemen. Scientific notation, this number should be any number between 0 and 10. That is 1, 2, 3, 4 to 9. Hello? Got it? That is the scientific notation. So 50 grams, how are you going to write? 5 into 10 to the power of? Minus. Minus how much?
Minus 2, sir.
Minus 2 kilos. Correct?
Scientific notation was between 0.5 to 5, sir.
Scientific notation was between?
0.5 to 5.
Where did the 0.5 to 5 came? Where did we use that? You have forgotten. Yes, anybody remembers? Prabhus and Aditis and all, come on. Adil thoda ye ho gaya, blank ho gaya. वो जो देखा आपने 0.5 should be less than or equal to, what is that? The number divided by 10 to the power of x should be less than 5. You are telling this? Mother? No, ನಿನ್ನೆ ಕಲಿಸಿದ್ದು ನೆನಪಿಲ್ಲ. ಇನ್ನು ಹೋದ ವರ್ಷ ಕಲಿಸಿದ್ದು ಏನು ನೆನಪಿರ್ತದೆ ನಿಮ್ಗೆ? For scientific notation, this digit should be any digit from between 0 to 10. Right? And followed by this 10 to the power of 2 kg. See, students, you have missed out so much, and this is physics. Not solving sums. Okay, and see our system now. And that is why you see now in industry there is one top position, second position, third position, fourth position, fifth position. So now most of you will be fifth, sixth position. You are all brilliant students. You will be in this position. You can never rise to these positions in the hierarchy. Most of you. Why? Because you see, if you have to go to these positions, you have to be perfect from the grassroots level. Then only you can design. See, these are all, supposing you are joined some design house. So these are all the designers. You see, you have to come to this level. So you can never be designers because if you don't know these things at this level, so you got to learn still higher. That is where our country is suffering. See, all our wonderful students, they somehow pass, they go to IITs, they go to that, this and all. But we are not able to design. See, anything, higher level design, we are going to foreign countries. Right? And there they pay $50,000 for an engineer who will work at this level. And they will clobber $5 million. Net profit. Okay? So that is because of this. So better now, if you want to be designers. Otherwise, you see, you will be helping the designers. You cannot be designers. So watch out. Right from now, you learn science properly, then you can rise to that level. Good. Now, I am teaching you everything nicely here. Please, with lot of love and affection, you learn. One experiment I will teach you very nicely. Remaining, you should do like this. You should do scientific reporting like this. Okay, you measured the mass. Then what else you did? Come on, continue.
Calculated the time taken for 10 hours.
Calculated the timer.
Measure.
So there is a difference. In journal, if you write calculated, teacher will also calculate -1 marks. So you measured the time. For that, what did you do? For that, what is the procedure you followed? How did you do? What did you do? Come on, tell me.
That will displace the mass by some distance.
By some distance. Okay. Right. Now watch out. That means you will keep the pendulum here, correct?
Yes. Very small.
That you should tell. That you should tell. That is important. That word small is important. If that word small is not there, your marks will also become very small. So you should tell. We pulled the bob, okay, such that it makes a small angle theta. Small angle theta. Don't say displacement. Small angle theta. And then what did you do? Tell me. So you brought it here and you left your hand, correct? Hello?
Yes, sir.
Then what did you do? You left your hand and then what did you do?
At the same time, we turned on the stopwatch.
At the same time, you turned on the stopwatch. That is, as soon as you left it here, you turned on the stopwatch, correct?
Yes, sir.
Did anybody do something?
No, sir. I met him, sir.
Yes, Abhinav, what did you do? Abhinav?
Yes, sir.
What did you do, Abhinav?
Started it, sir. We left the box, sir. Then when it reached the other side, we started the stopwatch because that was easier to do, easier to handle.
Okay. So you are telling that when it reached the other end, you started the stopwatch. Who told you to do like this?
Yes, sir.
Who told you to do like that?
Nobody.
Nobody. You used your own brilliance and did it. Fine. But both of you are wrong. So you should start the stopwatch here. Get it? You should start the stopwatch there, not there. Because you see, students, now try to understand. Here we have assumed that there is no friction. But there can be. So therefore, the next time the bob is going to stop, it may not stop there, it may stop here. Slightly lesser, not so much, slightly lesser. Got it? So the best place to get the accurate reading is this. So you leave the bob, and then when the bob comes here, you start the stopwatch. And then you should set your eye to this position. So you have started the stopwatch, right? So it goes here, it comes here, again it comes here, 1 count, 2 count, like this. So your counting should be around this, because as the number of oscillations keep increasing 0, 1, 2, 3, 4 to 10, the amplitude will go on shrinking. I suppose all of you can understand that, right? Hello?
Yes,
so you should observe it at this point, okay? Then only you will get most accurate. See, your experiment should be to get most accurate reading. You got my word? Not doing anything. Okay, see here there is every possibility that it will not stop here. And for you to, set your eyes here. Where will you set your eyes? Here you will set, or here you will set, or here you will set. Difficult. but to set the I here is easier. So small angle theta, and you will start the stopwatch the first time it crosses the mean position, and then you count the number of times it crosses the mean position in a particular direction, say in the bracket right or left. That is, you have now counted when it has gone from here to this, and second time when it comes here and goes here. Understood? It is not just you do it, or you do it like this. Every time it comes here, you count. But if you count 20, that means it has done 10 complete oscillations. That is another way of it. And all this, see, such questions will be asked. Okay, and you are going to get very interesting questions at the mains level. They are going to coin questions, in such a manner that if a student in the laboratory has conducted it properly, then only he can understand that question and get the right answer. Right. So you will count 20 oscillations here. Right. So after counting 20 oscillations, then you will divide it by n. Correct? You will divide it by, say you got 20 oscillations, so you would have got some time period. Correct? Hello? Hello? You will get some time. You will get delta t. You will get delta t1, time taken for 20 oscillations. You will divide it by 20 and you will write it as t1. Correct? This is what you did?
Yes, sir.
Then what you did? Then what you did?
Repeated that experiment.
Good. You repeated that, then you got T2, then you got T3, and then you added T1, T2, T3 and divided by 3. So you got what? You got from all this what? Mean value of time, correct? Mean time period you got, correct? And then what did you do?
No.
That's all. So you wrote the time period and you came up. नहीं जी, नहीं, ये एक्सपेरिमेंट नहीं है, ये छोटे बच्चों का एक्सपेरिमेंट है. इससे आपने सिर्फ you have determined this value. You have simply determined this value. You have not done anything more than that. You have not done anything more than that, and that is not. See, now let me tell you. So let me tell you, you have done that. See, your answer should be, your experiment should be to give G, and you are going to write the value of G as some value plus or minus delta G. So if you are reporting your answer like this, then you have completed the experiment. Otherwise, you have not completed the experiment. Are you with me? So here you see your experiment, after finding T, your experiment will be like this. That is, your final calculation part will be like this. Delta G by G is equal to, you see here, delta L by L plus, you see there, 2 delta T by T. Hello, are you with me? So here you see what is delta L by L. Now you have used a scale which has got least count of 1 millimeter, correct? It got a least count of 1 millimeter. So supposing you have got a least count of 1 millimeter and you have measured the length of the bob. Say length of the bob is something like around 90 millimeters. So you write here millimeter, they will cancel. Here you don't have to write SI unit. So 1 millimeter upon 90 is L plus 2 into your stopwatch. What is the least count of the stopwatch? 1 second. Hello? 1 second upon 1 second. So 1 second divided by whatever time you have got in seconds. Right? Whatever time you have got in seconds. So here supposing you have got you have taken 20 oscillations and you have got say something like around T is equal to 20, something like that. You write it. The time period is 20, whatever you got. Okay? And this into this. So this will give you a value delta G by G. Correct?
Yes, sir.
This will give you value delta G by G. Great. Now, from this experiment that you have got here, you would have got this time period. You would have substituted all these values. Hello. So you would have got the value of G here. Hello.
Yes, sir.
Say you have got a value of G as something like now here. Say 10.1. 10.1 meters per second square. Correct? Something like that you would have got.
Yes.
Now that's it. So from this you will get delta G. So this G value you will substitute and you will calculate delta G. Delta G will be whatever G value you got here into all these values. So you will get delta G. So final reporting will be this plus this. This is the complete experiment, and this is the experiment prescribed for your mains examination. And you were supposed to conduct this in your college. For whatever reason, you have only found out time period, God save you. Okay, did you get it, students? So, every experiment that you have conducted, you once again revisit and see from the viewpoints that I have told you. Check out. And that is how you have got to conduct this. Okay. Shall I proceed? So it is not just go to the laboratory and do something and come out. You have got to learn a lot. And especially if you want to become good engineers, then your laboratory work is extremely important. Okay. I suppose all of you can read this. Okay? This is precisely what I have explained. Right. So you want to write everything in detail. Right. Then ultimately, you see, this is another point which I missed out. Okay, this is another point I missed out. Plot the length
Sir, we have done this.
Plot the length versus graph and length versus time squared graph. This is precisely what you are going to do. Calculate G and the percentage error in G for each length. Okay. Compute the acceleration due to gravity for each pendulum length. Determine the average time for 20 seconds. So this is the procedure. This is precisely the procedure that you have to follow. Okay. So now directly I'll give you a numerical on the experiments. Now if you have understood what all I have taught, you will give me the right answer. Please do this. So error limits means you have to determine this. Okay, ask. Good. So final reporting should be this G plus or minus. Right. So what is your final answer? What is your final answer? Now be careful now. Your significant digits, everything will come into picture.
See, my side
you got to report
10.06 and plus 0.2.
10.06
meters per second. Plus or minus 0.2 meters per second.
0.2 what?
Meters per second.
Okay, 0.2 meters per second. Well, you seem to have answered very confidently. I'm happy for that. See, I want this, all of you do it correctly, right, to the best of your ability, right, and be confident and give a nice, confident answer. Okay, you see, right or wrong is a secondary thing, but this is something, now everybody should be, conversant with. That is, you should be able to use the science to the best of your ability, solve it confidently and report it confidently. Submit it, it's okay. Let the teacher decide whether it is right or wrong, and if it is right, fine, you go ahead. If it is wrong, you be very happy that you have got an opportunity to learn. This is the mindset. If it is there, then chances of you doing well in the examination is very, very high. Okay. right? So T is equal to 2 pi. Now the period of 50 oscillations is 90. That is precisely what they have given, right? Okay, so the time period is 1.96 seconds. Did you get this? Hello? Hello?
Yes, sir.
Good. And did you get this?
Yes, sir.
Yes. Now I want to ask you directly here. Right, here you have got this, here you have written this, right? And then, I think this is the formula that I wrote. This will be into, and least count is 1 centimeter, and least count is 1 second, right? Delta G. Delta G is 0.3 meters per second square.
So that should be mine. Yes. Yes, sir.
Okay, right. Now the question is the final reporting. The final reporting, right? So this is given to 3 decimal places. Sorry, 3 significant digits, and this is given to 1 significant digit. Now, how will you justify this?
Person's time period is in 3 significant digits. That's the minimum answer. So from there, 10 point.
No, how did you get 10.1? Why did you stop at 10.1?
So the least significant digits from time period 1.96.
1.96. Okay. So
the final should be in the least one.
Final one should be in the least one.
Yes, sir. Because division algebraic operation.
Somebody else can. I am not understanding what you are telling. Why there should be 3 significant digits there, and why only one? Why it should be 10.1? Why did they not keep it at 10.06?
When calculating that value of G, sir, we have divided it by 1.9.
No, this value you just divided and got it, you have written there. You have written there. What is 1 by 98? Hello? What is 1 by 98? Somebody answer 1 by 98.
0.0102.
0.0102. Okay. Now this is what 1 centimeter in 98 centimeters, correct? Correct. 1 centimeter divided by 98 centimeters, correct?
Correct.
So the 1 centimeter upon 98 centimeters. So if you are using a centimeter scale, so 1 centimeter, then come on, now I am bringing you closer to the answer. And the answer is in meters per second square. You watch out. So if you were to write this in meters, you would have written it as what? 0.01 meter divided by 0.98 meters. If you are supposed to answer in meters.
Yes. Still we have only 1 significant.
Wait. Till you have got only 1 significant. Now come to this point. 2 upon this. So 2 upon 98. So 2 is in seconds, 98 is also in seconds only. Correct? Come on, yesterday we have discussed this issue.
Sir,
Huh.
we can take only one significant figure over there in the answer, sir. We'll get 0.01. You should consider, sir.
Where at what point?
At 1 by 98.
1 by 98. Okay, 1 by 98 you will get here one significant figure. Correct. Okay.
0.01. And 2 by 98 it will be 0.02, sir.
So you will get here 0.01 here. Correct. Right? Because in this you have got only one significant. That is the answer. So here you have got to report it as 0.01. Right? And the other one you will get it as 0.02. So in both the cases you have got only one significant digit.
So we, like while adding, we should be see the number of decimal places.
Number of decimal places. So therefore you will bring it to one decimal place. That is the answer that I was expecting from you. Correct. Did you understand? Hello?
One doubt, sir.
Hi, yes, please.
So that delta T by T, sir, over there, shouldn't we consider the T time period of oscillation?
Time period of?
Oscillation, TS.
No. Well, since time period we have done, no?
No, sir, we have taken 98, so we should take 98 by 50.
98 by?
Like time period of oscillation should take as T.
That's a good question. But what is done here is also correct. What is done here is also correct. Because, listen here. What is delta T? What is delta T?
Least constant.
No. See, here you understand. Here, delta T is actually the error. Okay, and see, now if you have the least count of 1 second, then the maximum error that is possible when you do it is 1 second. So delta T is error. Error is 1 second. What is the maximum value of the error? See, if you have a scale of, say, for example, 1 millimeter, then you see, now understand this. So I have a scale in millimeters. Okay, so I am going to report it like 1 point, say some measurement. Adil will report it as 1.2 millimeters. Abhinav will report it as 1.3 millimeters. Okay, then Anushri will report it as 1.4 millimeters. Okay, and Naman will report it as 1.5 millimeters. So on and so forth. Who is right and who is wrong? Hello?
All right.
All are right. So therefore now the maximum error can be, in reporting this value. And this value can go from 0 to 10. So that means now the maximum error here can be 1 millimeter. Correct? Understood? The maximum error can be 1. Now here you see, student. Here delta T by T, when you write here, so if you want to say I want to divide this T by 50, then you have to divide delta T also by 50. You got it? See, in the time, see, you are now taken what? You are now taken, see, what is this T? This T is the time for 50 oscillations. In 50 oscillations, right? In 50, see, you have got, now look at the reality. You have got a stopwatch. Hello? Right? Hello? Can you see me? Right?
Yes.
So the stopwatch is showing in seconds. Tuck, 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 tuck. Now listen to me and also think and also imagine what is there in the laboratory. So here you see tuck, tuck, tuck. That means now when the last count is taking place, where are you going to plus the stop button? We are going to plus the stop button when the stopwatch is at 0 or 0.1 or 0.2 or 0.3 or 0.9. See, the last stop when you give. So that becomes delta T. So at the end of the 50th oscillation, right, the last time what you have noted could have been what? It could have been 97 also, it could have been 99 also. Maybe in Herbert you would have stopped it at 98. Actually, it was 99. Okay, maybe it was 97. You have stopped it at 98 maximum. Oh, gadbad ho sakta hai na? Oh, kata. See that kata. See now here least count means what? See, it is doing like this. Tuck, tuck, tuck. That means now if you see in all Olympics and all, they will not use seconds. They will use milliseconds. You see that 1, 2, 3 will be in milliseconds. You see those stopwatches there. Understood? So supposing you had a better stopwatch which will measure it in 0.1 second. Okay, then you would have got more accurate answer.
Okay.
Do you understand? So therefore the delta t there is the error, right? And t stands for, you have made 98 measurements. Of course, this t here and the t that is appearing in the equations are one and the same. That is a mistake. That should not have been there. You would have written here some other, some other t there. But that's a good observation.
Sir, the least count, that would swing per oscillation.
Pardon?
Measured with the help of 1 second.
Correct. Now see, Arun. Now you should not go by numbers. Now you see the reality there. You have got a stopwatch. You are seeing the oscillations. Okay. Now you see. Now you are counting what 50 oscillation. Okay. 49 you have counted. Okay. 49th oscillation. Right? Hello.
Yes,
Now 49th oscillation. Then it goes here. It goes here. It comes here. It again comes here. Now at the 50th, see the bob is coming here, right? Bob is just crossing this. So the bob is crossing.
Yes,
The bob is crossing. So now here you see, you can press the stopwatch here or here or here, somewhere here. Hello, is it clear? So here you may press it at any of these points. So the likelihood of an error can be maximum 1 second. That is what is recorded. Okay, or in other words, you see, the stopwatch has to go from what? The 97th to 98. Correct? Now 97 to 98 it is going. Hello, are you with me? Wait a minute. 97 to 98, the second you are going. Supposing you press the stopwatch here. See, it was showing 98. It was going to 98. You press the stopwatch here. So that means it is 97 plus something, but less than 98. Got it?
That means again in that oscillation, that means 1 second.
In that time, in that stopwatch, see, you listen to me, man. The stopwatch was showing 97. See, it is 97 and it was going to 98. Got it? Hello?
Yes, sir.
In between 97 to 98, you have got still 1000 milliseconds. Correct? So, you must have pressed the stopwatch here. Or you would have pressed it here. Or you would have pressed it here. Clear?
Yes, sir. Yes.
So that means now you would have actually pressed it here, but the stopwatch will continue to come here. Got it?
That means, sir. Okay, like that. Okay.
So that is how you will see there. See, when you measured the pencil yesterday, I told you.
Error in the stopwatch.
Error in the stopwatch. And that is the least count. See, even when you measure the pencil, error, see what I give you these readings 1.5, 1.4 and all these things. They are the different readings. So it is error of judgment. And the maximum error of judgment when you have a pencil with a ruler can be 1 millimeter. That will be the least count.
Yes, sir.
Understood now? Good. See, you must get such doubts and you must ask questions and you must clarify. And why I am stressing so much is your questions in the examination will be precisely based on this. They know how to coin the question. If a student has thought about such a situation, like now one of you said, sir, this t should be t by 50. And now Arun is asking, so how this is so and so. So such doubts should arise in the class. Right? And through discussions, it should be clarified. This is science, and this is precisely what you want to learn. See, rest of the things are written here. Oh, I read this and I have understood. Least count is 1, so right. Why should you write delta t is least count? Now, I suppose you understood. Delta t is what? Delta t is the error, and incidentally, that error is equal to the least count. Understood? Actually, it is error. I suppose I made these things clear to you. Hello, everybody there?
Yes, sir.
Please. Right. Please learn now. Learn properly. Don't worry. Your examinations are still a long way. Not very long way. But whatever it is, you learn properly. Okay, whether you get good marks in mains and advanced and all, well, only time will decide and how you wrote in the exam. But one thing is for sure. Next year, if at all you go to any engineering college or medical college or any research, you will be wonderful students. You can learn very good books. You can become wonderful people. You don't have to put your head down. You can always keep your head high and you can do a lot of good things for yourself and for the country. That's for sure. But if you learn hand bundle like this, you will be good for nothing. Okay, you'll spend most of your time searching jobs. Okay, and haggling with your bosses. Right.
Sir.
Haji.
Sir, that delta G, sir. Previously. They have multiplied all the times, so it should be 10.1. Delta G equal to.
Delta G, what is that delta G they have multiplied? What did they say? Here, they are multiplied by 10. Okay, fine. That's a good observation. That is a good observation. That's a good observation. Very good. Correct. What you have said there is very, very correct. Okay. So there they should have written it as 10.1. I am sure. You are right. You are correct. This they should have written it as 10.1. You are right. But I don't think in the multiplication that would have made a lot of difference. But your observation is correct. I admit that's a mistake. So you see, even because these things, if somebody practices there in and out every day, then he is fluent with this. Okay. Otherwise, you have to, you have to stress very hard, when you write these things, see 10, 10.1 and all. We tend to overlook because our day-to-day calculation, we don't find significant figures and all. So, when we have to write 11, you go and ask your father 11 rupees. How will you ask your father 11 rupees? You will ask him to give you 11 rupees, correct? Hello?
Yes.
But frankly speaking, in science, okay, when you are writing, in science, so 11 should be written as 1.1 into 10 to the power of 1. Whatever you write. But definitely in colloquial language, you cannot go and ask your father, give me 1.1 into 10 to the power of 1 rupees. Okay, then your father will think I sent him to this college and this fellow became mad. That is not the thing. Colloquiality. Okay, there you cannot change and don't try to change. But in scientific notation, you have got to write it 1.1 into 10 to the power of 1. So therefore we are used, 1,000 times a day, we say 11, 12, 13 like this. But when you have to write in science, you got to be very careful to write it as 1.2. It is difficult. But what to do? Now you have got to be ultra careful and write these units and all very carefully because you are going to mark the answers in your OMR sheet. Very precise answers. I'm sure you know that. And if you ask last year 2 of your friends, okay, they got the answer wrong, but they instead of writing 10.4, he wrote it as 104. Okay, the point he missed, and so he lost 4 marks, and he lost his final rank by a few thousand ranks. Okay, there are many stories like that, just because of the errors in this. Right, students. Oscillations amplitude should be kept small, 10 or below, as the formula for time period is applicable for small angular displacements. While measuring the length and time periods, on average, several readings should be taken. The instrument use should be checked for 0 error. These are the precautions.
So your early instrument is stopwatch.
Pardon?
Instrument means what?
Whatever instrument you are using. Yes, of course, here is the stopwatch. And your ruler scale that you are using is also an instrument.
Yes.
Anything that you are using for measurement.
Yes.
Right. Graphs. The time period of a simple pendulum is affected by the following factors. So T is equal to T square. This is very important. You see here the graph, which is correct here. So here you see T is proportional to this. Wrong. T square is proportional to L. This is the right graph. Correct? Hello? Then time period is a function of acceleration due to gravity. So T square is inversely proportional to 1 by G. So G increases, this decreases. So which is the right graph? This is the right graph. Right? Hello. Then time period is independent of the mass. Pardon? Okay. Yeah, in this case, correct. In this case, T is proportional to 1. Sorry, yeah? No, here T is proportional to 1 by T is proportional to 1 by G, man.
But
It is fair.
graph mentioned. On it. Even first one.
T is proportional to 1 by G. T to 1 by G, then you are going to get it like this. And here, sorry, yeah, good observation. This is proportional. Excellent. Correct. Thank you. I saw the first one and I just marked. I'm sorry. Correct. You are right. Perfectly right. I think in first one also it is correct. Yes. In this also all three are right. I'm sorry. Yeah. Thank you. I just overlooked. Thank you. Time period is independent of the mass of the ball. The wooden ball, steel ball have the same time period if other factors are same. If the time period of this independent pendulum is independent of the amplitude, provided amplitude, the type of motion is called isochronous motion. Time period is independent of the amplitude, provided amplitude is small, the type of motion is called isochronous motion. Okay, fine. You know it. Hello, I think I have done justice to this. Hello, are you with me?
Yeah.
Okay. Okay, we'll not go to Ohm's law. Tomorrow we'll go to Ohm's law. Now I want to ask you a question. Hello, are you all with me? Hello?
Yes.
Now I am giving a typical situation. Okay, now this is a hollow sphere. Right? Hello, are you with me?
Yes.
So here the time period of oscillation is T1. Right? Assume the time period of the hollow sphere is Th. Right? Now, supposing I fill it with water. Now I will get the time period with Tw. Right? So what is the relation between Th and Tw? Which is big?
Both are equal.
Both are equal. Correct. Because it is independent of the mass. Done. Clear?
Yes.
Alright. Now.
Yes, sir.
Now. Yes, sir. Yes, sir. Good, sir. Now. I will make a small hole here. There is water here. I will make a small hole and set it to oscillation. Now, tell me the plot of the time period versus time. I made this. See, for this here, what is the graph of the time period versus time? What is the graph of time period versus time for Th and Tw? Straight line. Right? For this, what is the graph of the time period versus time?
Some time T equal to 0, sir. There will be 1.
T is equal to 0. Okay, you are right.
There will be some.
There will be some. Right. There will be some. Right. Right. Continue.
It will go on increasing.
It will go on increasing. Right.
Straight line increasing.
Straight line increasing. Correct? Correct. Hello, everybody agreed? Why?
Yes, sir.
Why will it?
Center of mass will change, sir.
Pardon?
So length of pendulum. Center of mass will change, so then length of pendulum changes.
Yes. So the this starts decreasing, so the center of mass keeps on coming down. Correct? Center of mass keeps on coming down, and therefore it keeps on increasing. Correct? Hello? Everybody agree?
Yes, sir.
Sure? Sure? Sure or no?
Yes, sir. Yes.
I want-
increase, sure, sir.
I want everybody to tell yes or no. Each one of you say yes, no, whatever it is. Yes, please.
Sure, sir. It will increase.
I want everybody to answer as it.
Sir, don't know about straightness, but it will increase.
It can't be be straight line, sir, because T is directly proportional to root L.
T is directly proportional to root L. See, now you see. So now whatever answers all of you gave is not correct, correct? Hello?
It will increase, sir, but not with, not as a straight line.
It will increase not as a straight line. Okay, I accept it. Not as a straight line, correct? Hello?
Yes, sir.
Right. I agree. So therefore, how can you, what can be the type of the line? Is the line like this or line like this?
So, one doubt, sir. So, small t, sir, is proportional to L, sir.
Small t is proportional to L. So you want to say small t is proportional to L.
Yes.
Are you sure?
Sir, isn't it proportional?
Are you sure? Are you sure?
Center of
Are you sure?
glory.
Are you sure? Small t is proportional to L.
L is proportional to small t.
So L is proportional to small t. Are you sure?
Sir, yes.
Think,
Yes,
see, students, you are going to write a very nice examination. Your alertness. See, I have been training you students, but you don't want to be trained. You are all, you just think something and then you feel you got the right answer. Why don't you ascertain what you are telling is right? See, now supposing instead of the sphere, if I had a cubical piece, and now I have a sphere. So here you see time is proportional to the length because the waterfall is uniform. But here you see the rate at which the water falling here and the rate at which the water falling here are equal. Assume. Hello. The rate at which the water is coming out, the rate at which the water coming out, assume they are equal. It will not be equal. Okay, the rate, but the height it is decreasing will be different here. It will not be linear. Here it will be linear. Here it will not be linear. Because here you see, for the same amount of water that is discharged in time delta t, this much water will be discharged. But in the next time delta t, are understanding? See here so much water will be discharged. But in the next delta time, only so much water will be discharged because the area is more. The length to which it will decrease will be less. Hello, are you with me?
Yes, sir.
Got it? So therefore, see, this rate is constant. So here you see, if you are students of physics and you are attempting advanced main NEET examination, then you should have said the volume decrease, the rate at which the water is coming out of this. That you have to determine volume as a function of the length. Then you will see how the length will be different. Anyway, I'll give it as a homework to all of you. Got it? Hello?
Yes, sir.
So you tell me what type of line is that, tomorrow you tell me. Right? That is point number 1. Now assuming the initial length will be sharp and then it will be less, assuming like this. So one thing is it can be like this. Correct? Can it be like this? See, till this point, okay, the slope and the things start coming here, the length will go on, the length at which is this, then something like this. Hello? Okay.
Yes,
Say now up to this point, whether the line is like this or like this or like this, you have to find it. Hello? Got it?
Yes, sir.
So now, when all the water comes out of the vessel, then what will be the time period?
Two constants.
Yeah, I wanted you to tell. Let the graph be like this or like this, that you find out. Here I wanted some fellow to use his brain and tell, then it will be like this.
Yes.
Yes, sir. I have told the answer. I wanted somebody to tell, see, sir, at this point when the entire tank is empty, then it will come down to this and remain constant. I wanted somebody to tell this. Okay, that's what I'm trying to tell. Pendulum is there, experiment is there, oscillation is there, but what is the type of question they are going to ask in exam? This is the type of question they are going to ask in exam. They are not going to ask you find out the time period to use the formula 2 pi root L by G. That all you have done in 10th standard. And initial, illustration problems you have done. But now you see you are going to answer questions like this. Mind it. And here I have told you a sphere. Okay, they can give you a cubical box here or a rectangular cuboid, So you got to deal with it. Or they can give you a conical box here. You see, they can increase the complexity just by changing the shape of the vessel there. Hello, are you with me? Are you with me?
Yes, sir.
Okay, fine. So that is one issue. Now you see right now on the spot I can show you so many issues like this, right? Now you see there can be like this. There is a fluid, right? There is a fluid, and well, you have got a pendulum here, and then you set it to motion, right? You set it to motion. Then they will give you the density of this. They will ask you to find the period of oscillation, whatever it is. That can be another problem. So you see, there are n number of problems like this asked. N number of problems. Then they can make it quite complicated and say, well, okay, there is a hollow, this one here, and there is this here. So in this, there is some oil, and then here there is water, and then they make a hole here, and then they set it to oscillate. Then what will happen? You can see the complexity. So therefore, I am trying to tell you, I cannot solve all such problems. There is no unlimited time available for me or for you, for that matter. But if you understand the science behind this, what are the concepts involved, how they get connected, then any such problem you will be able to tackle. Okay, so that is how you have got to think. Clear? Please do that. Please do that. Okay, and you train yourself. You take responsibility for learning. Now, what you are doing is, you are throwing all the responsibility on the college. Oh, let them solve, we will learn. And let them solve, we will solve. Let them solve, we will solve. See, the most important thing, it is not the number of problems that you should solve. But you solve little problem, less number of problems. But from every problem, you should learn something new. Okay, if that is happening, then you are on the right path. But if you are simply taking 100 problems and simply applying formulas and doing it, you are doing donkey's job. Okay, that will not give you dividends. Fine. Okay, I hope I have